Hello dear children, in today's class we will be discussing the horizontal projectile motion. In a previous class we covered just it's an introduction part, I can say that. So what is a projectile, what is a projectile, what is the projectile motion, how can we say that projectile motion is a two-dimensional motion, and there we discuss conditions and the types of projectile motion. So in today's class especially we are going to focus on only on horizontal projectile motion and the components or parameters related to the horizontal projectile motion. So before going to start the concept, before going to start the discussion, dear children, few things we need to recall. First one, the conditions for projectile motion. Dear children, the first condition, the height of the projectile should not be a very large. Second one, the range of the projectile also should not be very large. Third one, the initial velocity of the projectile should not be very large. Otherwise, G value will change. But as per our discussion, G value remains constant, right? That's what these things should not be very large. And one more very important thing. What is that? Air resistance must be neglected. Dear children, as air resistance must be neglected, so how many forces will act on the projectile? Only one force, one and only one force acts on the projectile, that is force of gravity, that to downward direction. So hence there is no force acts on a projectile in a horizontal direction. Only the force acts, that to gravitational force acts on the projectile downward direction only. Hence there is no acceleration in a horizontal direction. Only projectile has some acceleration in a vertical direction. So these are the conditions. And here why how can we say that projectile motion two-dimensional motion? The children, already we discussed that projectile motion can be resolved into two simple motions, means horizontal direction, vertical direction. You may get one doubt, sir, why it is resolved into two components, two simple motions? Because projectile has some velocity along horizontal direction, along vertical direction. See, along what we can say horizontal direction, let us say it's a ux, whereas along vertical direction it is a uy. And we know that, so along horizontal direction no force acts, hence acceleration also zero. So this horizontal component of the velocity remains constant, That's what we can say that the motion along horizontal direction is a uniform motion. It is a uniform motion. Whereas when you just think about the vertical component, in a vertical direction, yes, force of gravity will act, means it is not zero. Hence there will be some acceleration. So here uy is a variable. Of course its direction won't change. The magnitude of the vertical component of the velocity keeps on changing. That's what this velocity is a non-uniform, hence its motion is non-uniform. So the simply what we can say, the projectile motion can be resolved into two types of motions, uniform motion and non-uniform motion. And moreover, these two motions are independent of each other. Is the point clear? So that is why we can say projectile motion is a two-dimensional motion. Is the point clear? Fine. Next, trajectory. What is the trajectory, children? The path along which projectile can travel is called trajectory. So the path of the projectile only, simply we can call it as a trajectory. So as I told you that in today's class we are going to concentrate on only horizontal projectile motion. Now look at here. Here is some building or some anything you can take, some building of height y. You can take h, you can take s, anything you can take because it's a variable, right? Okay, fine. So from here point O, object is projected horizontally with the initial velocity u. Try to understand. It is projected horizontally only. But do you think that the body will be going along a horizontal path only? No. Straight line path? No. Why? Because continuously a force of gravity acts on that projectile, that too vertically downward direction. Of course, horizontal direction its velocity remains constant, but vertical direction, the vertical velocity keeps on changing as gravity is pulling downward direction. It has an acceleration vertically downward direction. Hence, it goes along a parabolic path actually. Of course, mathematically we have to prove that. Mathematically we have to prove that. Now we are going to discuss a few parameters. First one, equation of trajectory. Second one, time of ascent. Third one, range. And the fourth one, instantaneous velocity. So the first one we are going to discuss is equation of trajectory. Equation of trajectory. Children, I told you what is the trajectory. So the path along which a projectile can travel is called actually trajectory. So what is the equation of trajectory? Equation of trajectory. Children, during the motion, what we can say, projectile can cover some horizontal distance, okay, that is x. Even it covers some vertical distance, downward direction, okay. So the equation which gives the relation between horizontal distance and a vertical distance covered by the projectile is called equation of trajectory. Children, I repeat once again. What is the equation of trajectory here? A projectile is covering some horizontal distance and a vertical distance. The equation which gives the relation between these two, horizontal and vertical distance, only we can call it as a equation of trajectory. So for this, let us consider the vertical motion. So vertical motion. So vertical motion. Children, in a vertical direction, that to downward direction. Of course, initially it has some horizontal velocity, but vertical velocity will be 0. So vertical direction, initial velocity will be 0. And yes, ay will be minus 0 because acceleration will be downward direction. And it is a reference point, downward direction. We can take distances or any measurements negative. That is, s is equal to minus u. Okay, now let us consider here, minus y, right? Minus 5. So we know that s is equal to ut plus half at square. Now just substitute here, this is minus 5. This term will be 0 because initial velocity in vertical direction is 0. Plus half minus zt square. So this will be minus y is equal to minus zt square. So this will be y is equal to half zt square. Y is equal to half zt. Let us say equation 1. It is a vertical motion. Now let us consider the horizontal motion too. That is horizontal motion. Horizontal motion. Horizontal motion. Dear children, along the horizontal, there is no force acting, hence there is no acceleration, hence velocity remains constant. That's what we can call it as a horizontal motion. We can call it as a uniform motion, right? So simply we can say that here distance is equal to speed into time. That's it. So here, so x is equal to u into t and t is equal to x by u. Let us say equation 2. Now here substitute equation 2 in equation 1. In the place of t, you can substitute x by u. So we are going to get y is equal to half g. This is x by u. It is a whole square. This can be y is equal to g by 2u square into x square. Try to understand. So it can be, children, y is equal to k into x square form. Y is equal to k into x square form we have. Okay, now, or if you want, you can write like this also, or you can write like this, right? X square is equal to 2u square by g into y. G into y. Is the point clear? Children, this equation is a nothing but the parabola equation. It is the equation for parabola, right? So it is a equation for parabola, and it is, it's a symmetry about y-axis, children. Very important. Hence we got, we derived what we can say, we just derived a equation of trajectory, and we got similar to the parabolic equation. So which means what here, the trajectory of projectile is parabola. It's very simple. So the trajectory of projectile is parabola. That is what actually we proved. Is the point clear? Children, what is equation of trajectory? The equation which gives the relation between horizontal distance and vertical distance of the projectile covered by the projectile is called equation of trajectory. Clear? Copy? Just copy this. Let me check. Are you able to see? Of course, yeah, you are able to see that. Okay, fine. And the second one. So this is the equation of a parabola. Equation of a parabola. Okay. So x square is equal to, so you can write constant k into y. It can be anything. Okay, fine. This is equation of parabola. Now, second parameter we are going to discuss is time of ascent. What is that? Second parameter is time of ascent. Time of ascent. So what is the time of ascent? Which look at here. As it is projected at a point O, after some time it is going along the parabolic path only, no problem, and it reached point P, right? So for this it takes some time. The time taken by the projectile to reach the ground. Okay, the point on the horizontal, what we can say. So from here it is projected. It is going zzz, it is reaching here. So for this it takes some time. This time taken only we can call it the time of ascent. Of course, even you can say time of flight also in this case. What is the time of flight, dear children? The time for which projectile remains in air. I repeat once. What is time of flight? The time for which projectile remains in air. So it is nothing but that only, right? Here we have only time of ascent, no time of descent here. Okay, fine. So means let us again, we need to consider the horizontal motion, sorry, vertical motion. So here let us consider vertical motion to derive the expression for a time of ascent. So as we know that, so s is equal to minus y, ay is equal to minus g, and what can we say? Of course, initial velocity in vertical direction is 0. So we know that s is equal to ut plus half at square. This is all y direction vertically. Okay, this is minus y, okay, and this will be is equal to, this is going to be 0, and this is minus half gt square. If you want, you can take it as a h also, vertical height. Vertical height you can take a h. So in that case this will be minus h. If you want, you can take as a minus h also. Nothing is wrong. You can give y also, height, right? Okay. So minus get cancelled. So then t square is equal to 2h by g. From this here, t is equal to square root of 2h by g. So children, so this is the expression for time of ascent. Expression for time of ascent. Clear? Yes. Now third one, range. Range of the projectile. Children, what is the range here? Yes, so during its motion, it covers, of course, some horizontal distance or vertical distance. At the same time, horizontal distance means the horizontal distance covered by the projectile during its motion is called range. Means simply a horizontal distance. So this is from here is thrown. Of course, it is coming here. So we need to check this point Q. Let us say this is point Q. Okay, this QP is actually, P means this is exactly this point. So QP, so is a horizontal distance. Sorry, horizontal distance we can call it the range. Sometimes we can use a capital R to represent that. Okay, see, variable means, children, you can use any letter, doesn't mean, it's not a problem, it is. Okay, fine. Now in a horizontal direction means horizontal range means range we need to calculate. For that we need to consider horizontal motion. But we know that horizontal motion is a uniform, right? Horizontal motion is a uniform motion. So there you can write directly x is equal to u into t. What is this t? Yes, here we could derive. So this t you have to substitute here. Let us substitute here. So x is equal to u into square root of 2h by g. So this is a expression to calculate the horizontal range. In the place of x, if you want to take r, no problem. If you can take x is equal to r, yes, you can write r is equal to u into square root of 2h by g. That's it. Okay, copy this. So this is about the time of ascent, and here is a what we get the range. Okay, children, copy it. 3, 2, 1. Okay, fine. And the last parameter we are going to discuss is that instantaneous velocity. Fine. Okay, so the fourth parameter is instantaneous velocity. Instantaneous velocity. Children, what is mean by instantaneous velocity? So we know that, children, so during its journey you can take at any point, it has two velocities. Some velocity along the horizontal direction that remains constant, and some velocity it has along the vertical direction. Okay, and it keeps on changing. So the resultant of the horizontal component of the velocity and the vertical component of the velocity at any instant is called instantaneous velocity. For suppose, let us take some point B. Okay, now here it has some what we can say horizontal velocity u. See, it is always remains constant, and let us say the vertical velocity, let us say it's a vy. That is at any point the final velocity in a horizontal vertical direction is the point, and the resultant of these two will be so along the tangent like this. So this is a instantaneous velocity at a point B. Now, children, here, so for this, first let us consider the vertical motion. So here along the vertical motion at any instant we are taking a certain after time t, the point what the projectile has reached point B, and by keeping the projectile here, now we are discussing. Okay, so here see, initially the vertical velocity is 0, no doubt about it, it's a 0 only. Okay, and here ay is equal to minus g. So children, we know that v is equal to u plus at, but vertical direction we need to apply, right? So this is how we need to apply. Okay, now this is going to be vy, this term will be 0, a is minus g, so it is a minus gt. Okay, is the point clear? Yes, it is a clear. Vertical motion, horizontal direction. In a horizontal direction, yes, the velocity will be u only. Why? U only, it remains constant, but this velocity with the time it is changing. As time changes, the velocity of the projectile to vertical direction changes, but whereas in a horizontal direction velocity remains constant. Why? There is no force acting on it horizontal direction, hence there is no acceleration, so hence velocity remains constant. Okay, fine. So here resultant means, if you can see, children, here again we need to apply the concept of a parallelogram of law of vector addition. These are two velocities are representing the two adjacent sides of the parallelogram. Then the resultant velocity is given by the diagonal drawn along the diagonal drawn for that parallelogram will give the resultant velocity. Okay, so that concept actually we are using. Okay, so here v is equal to, so as per that actually here u square plus vy square. So actually this is a formula here, resultant velocity is equal to p square plus q square plus 2pq cos theta. But here what is the angle between these two vectors here? 90 degrees, right? So cos 90 is 0, so this entire term will be eliminated. Only we have two terms, p square plus q square. So let it be, this is a p, this you can take as a q. Then that is how we applied here. So here if you can see more, v is equal to, so u square is u square only, but vy is minus gt whole square. So this is going to be g square into t square. So children, this is a magnitude of the instantaneous velocity. So velocity of the projectile at any instant, as the time keeps on changing and the enter value will be changing, hence this velocity also keeps on changing. Then what about the direction? Because we need to know even directionals, right? So let it be this horizontal component of the velocity makes an angle beta with the resultant with the resultant velocity v. Okay, now children, so let us complete this as a triangle. Look at here, yes, and any vector can be shifted parallel to itself. So hence this final diagram I can write like this. Here is a point B, yes, this is u, yes, this is resultant velocity, and this can be v, y, and it is beta. Okay, now from this I can write here tan beta is equal to, so children, is opposite side by adjacent side, try to understand, opposite side by adjacent side, so that is vy by u, but vy is what actually, minus gt by u. If you want, you can take a magnitude, just gt only you can take. Okay, and beta is equal to tan inverse minus gt by u. So this is the direction, it is the direction of horizontal well, or else this resultant vector makes that much angle with the horizontal. Is the point clear? Yes. So children, this is all about the horizontal projectile motion. This is all about the horizontal projectile motion. So you must be very careful. Only you should have an idea, children, why a projectile motion is a two-dimensional motion. So that is what actually you keep on thinking. Once you can understand that, then you will think easily that yes, projectile motion can be resolved into two components. Sorry, two what we can say motions. One is the vertical motion, horizontal motion. So about that, just you think that, and in each and every step we are going to use the same concepts. Is the point clear? Yes. So in the next class, we will be discussing the inclined projectile motion. Means a projectile is, means it is a thrown from the, what we can say, from the ground only, but with a certain angle, some angle. So in that case, so we are going to talk about the trajectory or equation of trajectory, even time of ascent, time of descent, maximum height reached, and the maximum range, and all these things we'll discuss. Okay children, thank you so much, all the very best.